Hi all. Welcome back to our channel Vision Port. So today we will discuss about the basic analysis. What? The basic analysis. The basic analysis of a program. So if you are a good programmer, definitely you want to analyze the data structures as well as the Python code or any coding languages. That is the basic thing. You want to crack any interviews and you want to become a good programmer, because if you know better in the data structures, you will definitely do anything faster. So that is the thing the companies also want, right? Yes, today we want to discuss about the basic analysis of coding. Coding means asymptotic notation. So we definitely know, as a programmer, we definitely know if you write a code, if you write a piece of code, definitely it will help or it will take less time as well as less space. Otherwise, what will happen? The performance issue. That will definitely impact on the client. So avoid this one. We definitely know what data structures we can use with our real life example. So today we will discuss about some of the example. So the first thing is data structure. You already know data structure. Data structures means different data structures are available. Each data structure is used for different purposes. So today we will discuss about two things that definitely has an important role in the data structure series. The time and space. The efficiency of data structure is always measured in terms of time and space. An ideal data structure consumes least possible time as well as least memory space. Then only we can say that that program or data structure is good working at the particular problem. You got it right? Yes. So that is the today's we want to discuss the least possible time and least memory space. How we can achieve it? We'll discuss. Yes. The coming to data structure, there is a two things which help to the important in the case of data structures, like time complexity and the space complexity. So what is time complexity and space complexity? The time complexity I will tell you. So today's lecture we will discuss about the time complexity. So later part we will discuss about the space complexity. So the time complexity, there are a lot of things we need to discuss. Let assume there is an array. You can see here, right? There is an array 1, 2, 3, 6, 7, 8, 9, 11. So this is the array. First we consider. We got a requirement. We need to enter a new value into this position. Okay, this position, the first position. What we can do? Normally, we are adding one extra column here and move the first element to the second element to the third to fourth to five to six to seven, this one, 7 to 8. Then that means shifting from one position to next position. That means the entire shift of the array. So that means it is lot of hard work, right? Definitely, because if the array is small, we can do this one. But if the array, for example, this array contain one core element, what will happen? The entire system, each and every time it will take 1 second. Okay, assume every shift, first shift 1 second, second shift 1 second. That means every shift it will take 1 second. That means 1 core second. It is huge, right? So this operation we cannot, it is not a good practice to perform this kind of operation with an array. So this is lot of hard work need for to computer. We don't know actually these kind of things, but definitely we need to know. The second thing is the linked list. So that the specific time we have an idea, we can use just linked list there. For the case of linked list, you can see here there's a block of elements. Block of element 1 is placed in here and 2 this block and 6 this place and the memory location also there. So there's a header point also pointing to the first element. This case it will be easy. What we do? We took this element, we took this block and attach the first end. Okay, we are attaching this element to this block into first and repointing to header point to the this one. So that will be easy. That means there is no shift, nothing, only linking the node to linked list. This node linked to this first of the linked list, and we pre-pointing this header point to this one. Simple. So this is the apt point. Okay, this is the apt one for this kind of solution. This is the idea we need to know. This is the thing we can know only doing the practice. That means this is the efficient and faster way. That means there is a conclusion. Need to compare the data structure. For example, if we want to find out a good data structure, or if we want to solve one problem, we definitely know different kind of. We have deep knowledge among the data structures and want to discuss and want to know which problem and which data structure is suit. Then only we want to write, or we need to write a good program, and the customer become impact or impressed. So remaining this thing, need to compare the data structure, and will ultimately give the ideal or the best possible data structure for a particular operation. This is very important, best possible data structure. Okay, so this is the conclusion among the time complexity. Hi, the last lecture we find out the time complexity or running time to operation on data structure. So we need to know, this is the one question I'm actually asking to you. How to find a time complexity or running time of an operation on data structure? Because if we find out the running time, then it is easy. We can know this data structure is suitable for this linked list or this problem. Okay, how we can find? There are some methods. You already know there are some methods are available. I'm just discussing it. First one is examine the running time. How we examine the running time? So first pick a machine. Run the data structure operation with the timer on. Run the data structure. If we pick a laptop and take the timer on, then run the operation and check the time for various data structures. For example, first you implement the array, then timer on, take the time, how much time is take to complete that operation, and next one you pick the linked list program and timer on, then take the time, then find out which time took less, then that would be the faster and efficient program. But it is not possible. Because why? Asking to why? Because we know it is not possible in real life example. Who will do this kind of things? No one do. So we need better analysis. And one more thing, one more method we can know. You already know different system. For example, if I am using an high processing system and my brother is using a less processing system, okay, or less memory or less processing systems, and then he also run the program and me also run the program, but it is different, depends upon the machine performance. That also very important. Some input size. Okay, first data structure gives better performance and other input size the best performance. So that is also, it might also possible in some machine for some input size. Some machine, some input size, some data structure will give better performance. At the same time, another machine, second data structure will perform the different size. So that means the time complexity has dependency with the performance of a machine and the data structure and the input size. So that is not it. So our conclusion will be examining the exact running time. Exact running time is not a best way to calculate the time complexity. Theoretically speaking, there is no exact way, because running a program and took the time and running another program took the time, it is time consuming, you already know. So the client will not allow such time for a developer to complete it. So that means there is no possible, this way is not an apt one. So we need to find out best way to find out the time complexity. So that we can discuss in the next chapter. Stay tuned.